Hi, how are you this morning? I hope you had a great weekend. This week we're going to work on circles and reasoning with circles. So let's go ahead and get started. One of the things I want you to know is today and tomorrow and Thursday, you will have, I'm going to speak with you like this, but the other Google Doc that is attached is what we're going to go over. And some of those you're going to have assigned, some of those problems, and then some of them we're going to go over together here. All right. So let's get started. The first thing we have is the angle measure and segment lengths. We have two theorems. Now, the one that you have looks a little different. Okay. It looks like this up here, the angle measure and segment. Okay. The angle measure and segment lengths. We have two theorems up here, Theorem 1 and Theorem 2. Theorem 1 says the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measure of the intersected arcs. So if I know what this arc is and this arc is, okay, I can add those together and take half of it and get the measure of angle 1. And since these are vertical angles, the measure of angle 2 also. Theorem 2 says that the measure of an angle formed by two lines that intersect outside the circle is half the difference of the measures of the intercepted arcs. So if I'm looking for the measure of one formed outside the circle, okay, I can take half of the big arc out here and then subtract that small arc. And I'm going to get that one in there. All right. So down here, I'm going to show you now what I have inside my book. All right, inside our books right here, we have three of them down here. Okay, and this is what I'm going to ask you to do: is just look at these. We have find the measure of angle 1. Okay, I'm asked to find the measure of this angle right here. Well, I can see that it intersects inside this circle. It intersects two lines, forms two lines. One of them is 52 degrees. One of them is 40 degrees. So my first theorem says that I can add up 52 and 40, which is 92, take half of that and get the measure of this angle that's inside here. So when I do that, I get that the measure of angle 1 is 46 degrees. Okay? This one over here is a little different. I'm asked to find the measure of angle 5. Well, I don't know what this one and this one is at this point, but I do know, and I can find the measure of this angle right here. That's going to help me because once I know the measure of this angle, a straight line is 180 degrees. So I'm going to add up 90, 120, take half of that, and I get that the measure of that angle is 105. If this right here is 105 degrees, it tells me that the measure of angle 5 over here is 75 degrees because that has to add up to 180 degrees. This is going to be long, so I'm going to skip this one. You can see it if you want to go back and pause the video, how to do that one. Example 2, the next one down here is using the second theorem, the one that I had up here, which says the measure of an angle that is formed outside of a circle. I'm going to take the large arc, subtract the smaller arc in here, and take half of that. So if I want to find the measure of angle MPN, I'm going to take half of 34 and subtract 18, and I find that the measure of this angle is 8 degrees. All right, and you can see these down through here. The you try at the bottom of the page, I'm going to ask you to do those three. All right, moving on the second page, we have a theorem that says for any given point in a circle, the product of the length of the two segments from the point to the circle is constant along a line through the point in the circle. These are three specific areas that you can look at with the circles and the lines going through those. If you have a scenario that has two lines, two chords that bisect, we can see that AB, the product of those, has to be the same as the product of CD. Okay? If you have two chords, okay, and they intersect outside the circle and on the circle, I can take the width of the one outside, okay, the length W, and add W and X, multiply those two together. And those have to be equal to the same thing on the outside. Y times Y plus Z. These are formulas that you can use, okay? And here's one. If it is tangent, and you know that length, you can use these three formulas to complete some assignments that are down below here, okay? So I'm going to go through these really quick, all right? So if I have right here, find in, this says circle, okay? In these circles, I want to find what these measurements are, all right? What are the variables? Right here, I can see 6 plus, okay, 6 times 6 plus 8 has to be equal to 7 times 7 plus y. I'm using this formula that's over here for the theorem. And this tells me that 84 plus 7y plus 49, because I distributed the 7 to the y and 7 to the 49, okay? This is just now algebra. 35 is equal to 7 times y, and y is 5. Over here, I can do the same thing. I can use this, okay, illustration that we have up here, because this line is tangent, and then this one goes through down and it ends at the circle. Over here, I have a chord, okay, and it goes, this is my chord of 16 units, and then I have 8 units out here and Z units on this side. So this tells me I can add 16 plus 8, multiply it by the area that's outside the circle, and that has to equal the tangent line to that squared, or Z squared. Do my calculation, and I get that Z has to be the square root of 192. And you can approximate that if you want to. Over here, I have an illustration like the very first one over here. 6.5 times m has to equal 3 times 7. Do the calculation, and m is 3.2. What I'm going to ask you to do is that you try underneath those in the algebra problems. If you have any questions, I will be available between 10 and 11 and 2 and 3 on Google Meet. Hope to see you there. Have a great day. Goodbye.